Okay, so the next topic we're going to begin today, if we don't finish it, we'll finish it after Labor Day. But I actually think you'll find this to be maybe even a little bit easier than what we just finished. Because I think a lot of us have some experience with lines and slopes. Okay, it's something that you talk about a lot in high school math. Like they introduce it in Algebra 1 and they cover it again in geometry, then they cover it again in Algebra 2. Like it's a topic they like to cover every year in high school. But it might have been a little minute, so let's talk about it. Okay, so the first thing is, what is slope in general? It's a measure of steepness. And I do want you to understand that that's essentially what it is. In other words, the larger the number, the steeper the line it's discussing. Another way to say it is it's a constant rate of change. It is trying to tell you how rapidly or quickly things are changing. Okay, so a large slope means things are changing quickly. A really small slope means things are changing, but not so fast. So we are going to be looking at graphs much like we read a sentence from left to right. So if you look from left to right, what would you say about this line? Is it going up or down? Up. So this is representative of a positive slope. So always read graphs again from left to right. This is going down from left to right. So what kind of slope do you guess this is? Negative. Even though I'm not putting numbers on this, which one should have the higher number slope and why? The first one should be a bigger number. How come? It's definitely steeper, right? This one is much more shallow than this one. Okay. So if you keep on that concept of steepness, how steep should a horizontal line be then?
Not at all.
Not at all. So what do you think the slope of that's going to be? 0. Okay. So it's got a 0 slope. And then the other special case is a vertical line. Notice this is incredibly steep, right? Like it's so steep that we can't define it, so we call that an undefined slope. Okay, like you can't even put a number on how steep it is. That's kind of a good way to remember it. All right, but the formula for slope, and different from your math classes in high school, for the most part, you're not going to get equations given to you in college level math classes, so you're going to need to kind of start committing those to memory. But the slope formula is always going to be the change in y over the change in x. So notice we have y2 minus y1 on top. Well, that's because that would be the change in y. And then we have x2 minus x1 on the bottom, because that would be the change in x. And the numbers just indicate that they're different y's. So this just says this is a different y from this one. And this just says this is a different x from this one. Okay. So let's do maybe a couple of these. I don't think slope questions are too difficult, but they are prone to maybe have sign errors in them if you're not careful. This is actually something that shows up in your competency exam also, so this will be kind of a good refresher before you take that comp exam in the next week. So find the slope between 4, -2 and -5, 10. So my slope formula has me look at the x's versus the y's. So if you need to, maybe a quick refresher on which one's x and which one's y, but they just go in alphabetical order. The first number's x, the second number's y. So I need to subtract the two y's. Okay, so I'm going to start with the second one minus the first one. Okay, so I'm going to have 10 and then minus -2. Okay, notice the slope equation has a minus sign in it, right? And then the y1 happened to be negative there. Okay, so we'll mess with that in just a minute. Because I made this my y2, I've got to make this my x2. Okay, so it actually doesn't matter which set of points you start with, but like if you start with the second group, then you have to keep starting with the second group. Okay, so this one I'd need to do -5 minus 4. Okay, so just work top out separately and then bottom out separately. What is 10 minus -2? It changes to plus, so what would it be? 12. And then what about on the bottom? What's negative 5 take away 4? Negative 9. So if you give my math lab this answer, it's going to say, hey, you've got the right answer, but you need to simplify it, right? Because what goes into both 12 and 9? 3, right? So what would this reduce to if I was writing it nicer?
4.
Yeah, so 4 over 3, I either need to say this, right, or I can put the negative on top, okay? It makes no difference where I put the negative, but it does have to be negative because it's a positive divided by a negative number. Okay, so your negative sign can go anywhere you want. It just has to go somewhere. All right, so let's do one more slope question, and then we're going to maybe use slope when we talk about lines. So what about this one? So find the slope between negative 5, 3 and negative 5, 10. So we're going to do our slope formula. Okay, so we're going to start with the second y, right? So 10 minus the first y, which is 3. And maybe the weirdness comes when we try to do the x part of this, right? So what's the second x? Negative 5, right? And if we subtract off the first x, notice I get minus a negative like I did before. So I get 7 on the top, but what do I get on bottom if I change those to plus signs? 0, okay? So notice it gives us an answer that's kind of the no-no answer, right? We're not allowed to have 0 in the denominator. So which of our special cases do you think that is, 0 on the bottom? Close, okay? But it is going to be undefined, okay? In other words, 0 is not allowed to be on the bottom, so think of the prefix un means not, right? So not defined. So it is going to be undefined if you get 0 on the bottom, and it is going to represent a vertical line. Okay, so without doing another one, let's make sure we know what it'll look like if we get a horizontal line. Okay, so if you get 0 over a number, notice the difference, right? Where's the 0 this time? On the top, and 0 on top is no problem. Okay, 0 divided by a number is just 0. So if you get 0 over a number, that's just 0, and then what would that represent? That would be a horizontal line. Okay, so you're not necessarily going to know you have one of the special cases. Just do the slope, and if you get 0 on top, it's horizontal. If you get 0 on bottom, think of it like you can't have 0 on bottom, so that makes it undefined. All right, so we're going to use slope in order to write equations of lines. So first, let's talk about, remember I put stars by things I really want you to know, okay? So linear equations basically have 1 or 2 variables in them, most often 2. And usually those 2 are x and y. But here's how you tell that it is linear. It has no x squared, no x cubed, no y squared, no fractions where we have a denominator that's a variable, no square roots with something under it, no absolute value of x, nothing fancy, in other words, okay? So I like to say it like this: we just have plain old x and y. Okay, so we just have plain x to the first power and y to the first power. Nothing fancy at all. Okay? If we have a squared or a cubed or a square root or anything weird like that, then it's actually going to be a different type of function. We're talking about linear equations that make lines when we graph them. All right, so I feel like probably a lot of you are going to remember this from the class before it. Well, one of your classes before it. Because again, you talk about linear equations and lines a whole lot in high school. But just in case you didn't, let's go over some different ways we can see linear equations. Okay, and we're going to use them all, really. The first way is y equals mx plus b. Okay, so I don't know if you remember that, but does anybody remember what M is? We kind of already did it today.
Slope.
Yeah, M is slope. Okay, does anybody remember what B is?
Y-intercept.
Yeah, B is the y-intercept. So this is called the slope-intercept form, and if you think about it, it actually is called exactly the pieces of information you get from it. Okay, so it's called the slope-intercept form because you can find the slope and you can find the intercept from using that equation. Okay, so I'm going to put a star by this one. This is going to be our go-to form that we want to use more so than the other two. All right, so here is the second format, though. It looks like this. Y minus y1 equals m times parentheses x minus x1. So there's a little bit more to this one. Okay, but m is still the what? What is m kind of always reserved for? Yeah, m is always the slope. And then x1 is the x value of the point. And y1 is the y value of the point. Notice, though, that I still have only plain old x and plain old y, right? I'm actually going to plug in numbers in for the y1 and the x1. So I'm still going to not have squared or anything fancy like that. This one, maybe not surprisingly, is called the point slope form. How come you think it's called that? Because it has a point and it has the what? It has the slope. Okay, so the name implies kind of what information you can get from it. And then there's a third form that honestly I don't care about near as much, okay, but I'm going to include it just because a couple of your MyMathLab equations or problems might involve this form. So this is what we call general form. A, B, and C are just real numbers. So what I mean by that is we can put any numbers we want in for A, in for B, and in for C. The benefit to general form is notice that everything's on one side and we have set it equal to 0. So occasionally we might want something in general form, but for the most part, the other two forms are going to be our go-tos. Okay? But this one is like the supreme one. This is the one that I'm going to want you to know the most because we're going to graph lines using the first form. Okay, so keeping these three forms in mind, we're going to do a few examples where I give you different information and we have to decide which equation form we want to use in order to come up with an equation of a line. So let's say that I asked you to write an equation of a line with a y-intercept of 5 and a slope of 2. So I've got three choices, okay? Really only two choices because I hardly ever pick general form. So what I like to do is I like to go through and underline the information I was given, right? I was told the y-intercept was 5, and I was told that the slope was 2. Okay, so what two pieces of information was I given in example 3? The y-intercept and the slope, right? So which of the forms would I use when I know the y-intercept and I know the slope? Even pay attention to the names if you want. The slope-intercept form is the one to use, right? So I'm going to use y equals mx plus b. Okay, and it's really pretty easy, right? I just need to plug the right number in the right spot, right? So what should go in for m? 2. And then what should go in for b? 5. And so it just looks like y equals 2x plus 5. Okay. How can you tell that's linear from looking at it? Plain old y, plain old x, right? That's how you tell that it's linear. Okay. Okay, so that's kind of an easy one, but what about when maybe you get different pieces of information? So what if I asked you to, again, write an equation of a line, but this time I tell you that the slope is -1, and I tell you that the line goes through the point -4, 3. So they're not on screen anymore, but you still have them in your notes, okay? So let's underline the pieces of information I was given this time, right? I was given the slope, and I was given a what? A point, okay? So which of the equation forms would be appropriate if I know a slope and I know a point? Point slope, right? So I want to use y minus y1 equals m times parentheses x minus x1. And remember, as you're doing this on homework, you want to start committing these to memory because you're not going to necessarily get them on a test. Okay, so let's plug it in the right stuff where it goes, right? So I'm going to start with m because it's kind of the easiest thing. Okay, so what goes in for m? -1. Okay. What goes in for x1? Like what is the first x, or what is the x value that I was given? -4. So notice I end up with a double negative there, right? Because the formula has a minus sign in it, but then 4 is negative. Okay, so make sure you include them both. And then what about over here? I'm going to end up with y minus the y value, which, what's the y value that I was given? 3. Okay. So sometimes on MyMathLab, it's going to ask you for more than one form. So if it asks you for point slope form, it's going to want you to just do one simplification. So if it says, hey, give the equation in point slope form, we're going to change that minus a negative to a positive. Okay, and that's as far as we would need to go. Okay, this would be the equation in point slope form, as simplified as we can make it. So point slope form always looks like that. It's y minus a number equals a slope times parentheses x plus or minus a number. But then really often it's going to say, okay, now that you typed it in point slope form, now I want you to go one step further and write it in slope intercept form. Remember how I said that's like the go-to form, okay? So in other words, it's going to want you to solve this for y. Okay, well, we can do that pretty easily, right? We just need to remember some of our rules of arithmetic, right? Like what happens with this -1? The -1 needs to go to how many things in that parentheses? Both of them, right? All of them, okay? So I need to distribute there, so that would give me y minus 3 on the left. What would it give me on the right then? What's -1 times x? Negative x, right? And then a -1 times a positive 4 would be a what? -4, okay? And then I'm almost there, right? I almost have it in slope intercept form. So what's the last thing I need to do to make it look like y equals mx plus b if I want that? I need to add 3 to both sides. So I want to get rid of the 3 here, and whatever I do to one side, I have to do the same to the other. So I end up with y equals negative x minus 1. Okay, so this would be the same equation of the line, or the line is the same, but it's just a different format. So this would be the slope intercept form. Okay, so notice both forms though have plain old x and plain old y. They're both the equation for the same line, but this one is probably the more useful of the two. Okay, so typically what we do is we might have to use a different format at first, but we try to in the end get it to look like y equals when we're finished. Okay, and if you're used to using your graphing calculators, remember you have to have it in that format to be able to use your graphing calculator also. Okay, so what about this one? So write an equation of a line through the points -3, -1, and 2, 4. So I have 3 formats, right? So I first try to use y equals mx plus b, right? How come y equals mx plus b just isn't going to work for me this time? Do you know what you need to be able to use mx plus b?
The line is it.
Yeah, well, you don't know the slope. I think we could get the slope, right? But you don't know the y-intercept, right? So notice I didn't mention anything about that, right? So you're not going to be able to use that. So what's your method, or what's your format when you don't know the y-intercept, basically? You use the second one, right? The y minus y1 thing. Okay? And I'm all on board to use this, but I'm actually not quite there yet, right? Why? What do I really not know quite yet? I don't know the slope yet, right? So I need to find the slope first. before I can even begin here, okay? But I have a formula for that, right? Like, I have a formula. What's the formula for slope? Y2 minus what? Y1, and then on the bottom, over x2 minus what? X1, okay? So let's find the slope first, and then we'll use that to move forward. Okay, so we'll take second y minus first y on top over second x minus first x. And remember what I said, just be super careful about your signs. What's going to happen to both of these pairs of negatives, actually? They're going to change to positives, right? So it's going to be 5 over 5 or 1. So I'm going to circle this, but like that's not my final answer. That's just what I need to get my final answer, right? I still need to write the equation of the line. I haven't quite done that yet. Okay. So now I'm going to use my point slope format. So the question is, which point should I use? Okay, and the answer to that is you can use either one that you want. Okay, you would get the same final answer as far as y equals mx plus b, no matter whether you use this one or whether you use that one. Okay, which one would we probably prefer to use though? Probably positive numbers, right? Like we usually don't love negative numbers, so I would probably use the positives, but if you use this one, you'll get the same exact answer. I'm not going to show it both ways, but I promise that you will. Okay, so let's kind of slowly write it. It's y minus the y value. Okay, so what's the y value from the point we chose? 4 equals the slope we just got, which was 1, right, times x minus the x value. And what's the x value of the point we picked again? 2. Okay, so by the way, if all the problem asks you for is point slope form, you're there. This is point slope form. Point slope form looks like this always. Y minus a number equals a number times parentheses x minus a number. But more often than not, it is going to ask you to write it as y equals. That's not too hard to do, right? Because what is 1 times something? Just itself, right? So we don't really need the 1. So really the only thing I need to do here is just add 4. Okay. So if I want to get y by itself, to put it in y equals format, it would just be y equals x plus 2. So this would be the slope-intercept form. What's the understood slope here, even though I didn't write a number in front of x? What's the understood number in front of x if there isn't one? 1. It's 1, right? So the slope is 1, and you can write 1x plus 2 if you prefer that, but you don't have to. Okay, so either one of those would be acceptable. Okay, so basically it's just you being able to kind of go through and figure out what information am I being given and how can I get an equation of a line from the pieces of information I was given. So let's do one more, and then we're going to look at how to write horizontal and vertical lines. They're actually very straightforward. We're just going to have to remember how to do it. So write an equation of a line passing through the point 1, 3, and it has an x-intercept of -1. So I wanted to look at this so that you didn't get confused later on. Okay. Notice this is not quite what I wanted, right? What kind of intercept would I prefer to have? The y-intercept, right? But I don't have that. But you can get information from this just the same. You just need to maybe think outside the box a little bit, okay? This does represent a point, right? If it's the x-intercept is -1, what point is that? Isn't that -1 comma what? 0? Okay. In other words, now it's just a problem exactly like example 5 before it, right? Now we have 2 points and we can proceed there, right? So which equation am I going to need to find first? Before I can even go forward, I need to know the what? The slope. Okay, so using this, I would say, okay, I've got 0 minus 3 for my y's, and I've got -1 minus 1 for my x's. So keep your signs straight, but I end up getting -3 over -2. But what's a nicer way to write that? Negative over a negative is a what? Positive. So my math lab's going to want you to give reduced answers. So we would say 3/2 is the slope. So now we just need to use our y minus y1 equals m times x minus x1 equation. Okay, because now we have a slope and we have a point just like we did in the example before it. So I'm going to use this point, but you could just as easily use this one. Okay, it really doesn't matter. But I'm going to use this one just because I want to show you that you'd get the same result either way. So it's going to be y minus 3, since I chose that point, equals 3/2 times x minus 1. So I want to make sure that we can handle fractions, because when you do slope questions, you're going to end up with fractions sometimes. So let's say that I asked you to write this as y equals when you're finished. So you would distribute that 3/2. So let's talk about what that gives us. It gives us 3/2 x minus 3/2. Okay, because 3/2 times 1 is just itself. So when I go to try to add 3 to both sides, some of us don't love fractions, and I get that. Okay, technically you're supposed to know how to do fractions coming into this class, but I'm not going to worry about that too much. Okay, so I'm going to show you how the calculator can help you out with it if fractions are shaky for you, but just know that that's something you're going to need to kind of get on your own in some way. So the calculators have a really great option, if you haven't ever seen it, for changing decimals to fractions. Okay, so we would do -3/2. That just means -3 divided by 2 plus 3. And then it's going to spit out a decimal for you. And then if you go to the math menu, let me slide this up a little bit. The math menu is right here. So if you go to the math menu, notice the first choice is FRAC, which stands for what? Fraction. And if you press enter twice, it will spit back out a fraction for you. So it tells us that 1/2 is 3/2. So what we end up getting is y equals 3/2x plus 3/2 in this case. They just so happen to be the same. Okay. So typically speaking, you wouldn't have a fraction for the slope and then have a decimal here. So typically you would have fractions all over. So make sure you either know how to do it on paper, or that you know how to make the calculator give it to you. Okay, so the last thing, and then we're going to pick back up with this section next time, is I want to talk about our two special cases. So how do we write horizontal line equations? Notice I put a star by this too. I'm going to want you to know how to do this. So horizontal line equations always look like y equals a number, always. They're very simple. They don't have any x's in them whatsoever. It always looks like y equals 4, or y equals 100, or y equals -10. Okay. So there's a couple of reasons why that happens. Okay, so I'm going to kind of draw a picture, but also kind of show some work here to explain why. Here's our normal format for a line, right? Y equals mx plus b. But what did we talk about earlier was the slope of horizontal lines, like how steep are horizontal lines? That was the vertical one, right?
0.
Yeah, so 0. So if we plug in 0 in for m, what's going to happen to that whole term right there? Like, what's 0 times anything at all? It's just 0, right? So we end up just getting y equals b, and that's just a number. B is just a y-intercept or a number. Okay. Or you can think about it if you're a visual learner, okay, because I know some of you prefer to kind of see pictures. So if I told you to draw the horizontal line at 3, okay, you would go up to 3, right, and then you would draw a flat line at 3. Okay, so the question is, why is the equation going to look like y equals 3? Okay, and the reason for that is the x value can be anything, right? Notice the x value goes from -infinity to infinity, but what does the y value stay steady at? 3. So the descriptor of that line is actually y equals 3. Okay, if you're curious as to why. So if you can remember that one, I think by default you get the other special case. So what would the other special case be? If we have horizontal lines, what do we also need to talk about? Vertical lines. So vertical line equations, what do you guess? What are they going to look like? Horizontal line equations look like y equals a number, so what do you guess vertical equations? Yeah, they're going to look like x equals a number. So there's really not a whole lot to these, okay? In fact, if we look at an example of these, it's kind of an either you know it or you don't know it scenario. So if I ask you to write an equation of a vertical line through a point, as long as you know the format, it doesn't require any work whatsoever. But if you don't know the format, you know, you can stare at a question like that for a while, so you do need to remember how they look. So how do vertical line equations look again? It's always just x equals a number, so you know it's going to be x equals, and then you just need to find what the x value is for that point, right? What's the x value in the point that I mentioned? -5, so that's it. Okay, no work to show, no fancy equations to use, nothing like that, okay? What if I would have asked you for the horizontal line through that same point? What would you have said? But before that, so the numbers, yeah, you'd say y equals -3, right? So make sure you have the x equals or the y equals. It's not just the number, it has to be the whole thing, okay? Okay, so next time we're going to finish up 2-3 by looking at equations of lines. And so when you go on your My Math Lab, because we're doing 1.5 sections per class time, there are going to be some class days where there's 2 homework assignments due. So make sure you're really paying attention to your deadlines, okay? How long do you have before your first attempt at the comp exam? A week from today, okay? So if you don't want to print out the honesty statement that you're going to need for that test, grab one on your way out. And then if you miss roll call, hang out and let me know you're here. And then other than that, I'll see y'all in a week, right? Because we're not meeting Monday because of the holiday. So I'll see y'all on the 9th. So did you do that thing on Friday? So the only thing that I was having you do that for on Friday was because I wanted you to practice using the scan scanner. So did you download that app yet or no? You got it? Okay. So honestly, you don't even have to do the whole thing. If you'll just do 2 pages of it, so you just open the app, and then when it asks you for options, you have to find it. You probably already signed it. Oh, do you know this person?
Yeah, I was here.
If you remember your sign it, right? Okay, did anyone miss roll call and wants to, okay, what's your last name? All right, gotcha. New email. Did you have a question, Chase? I'm showing how to use Can Scanner real quick.
So I have work.
Well, ain't no point of doing that. That's what she's doing with my number.
I can't do the homework right now.
Okay.
I'll just give it to you tomorrow.
Darn it.
Well, I mean, you have a whole week. So like what I was assigning you today, I mean, but you had
You got both my number.
a week.
All right, talk to
Oh,
me.
you just got it. Gotcha. Okay. So have you already like signed up for an account or not yet? Oh, never mind. Have you already logged into your account through D2L? Like, have you
Yes,
looked at it at
ma'am.
all?
Yeah.
Okay. So like, you already did you do any of the assignments yet? Did you do the
No,
one
ma'am.
through Monday? Okay. So you're not gonna be able to get into those. So shoot me an email tomorrow and I'll get you some sort of password.
Okay.
And I'll give you an extension just because you weren't in this class till the end, but like normally speaking, you get a whole week, so,
Okay, I
yeah.
appreciate it. Thank you.
So the one for today, I would go in there and do it early so that
Yes,
you're
ma'am.
not stuck with the
Okay,
deadline.
I
But yeah,
appreciate
shoot
it.
me an email tomorrow and I'll get you a password that should get you into those assignments.
I appreciate it. Thank you.
Is there any way you can bring me a copy of the notes she did today in class? Because I have trouble, like, she's looking at mine.
Yeah, I have a video of them, so you could like fast forward through it or whatever. So if
She
you'll,
added it to the group chat, you can just do it. Because she puts it on she records everything that she
Yeah.
does, so you can take your own notes, so you can learn how to do it.
yeah, so, you have to, like, later on this afternoon, I won't have it up until then, because I have to, like, upload it to YouTube, it takes me a minute. But that way you could, like, because you took some of the notes, you just want to fill in some gaps.
No, it's just, when I look back at my notes, I have a hard time understanding my own, and yours seems more urgent.
Oh, okay. Yeah, I mean, I'll make you a photocopy, I can do that. So, let me get them in order. Is it okay if I, like, scan them to you?
Yes.
Yeah, I'll just scan them to you, that'll work. But then, like, if you wonder, like, well, how'd she get that? You can still look online and see that.
Okay.
So, anyway, I'll do that. Shoot me an email later, like after class sometime, saying, hey, Miss Newton, remember you were gonna send me the notes for today. That way I can just reply to that email and I don't forget.
Okay,
Because I have a class right after this one and I might forget.
all right, thank you.
Okay, so does it give you an option to take, yeah, so if you hit the camera, and it should say a batch. So anytime it's more than one page, you want to use a batch. So just take a picture of the first page, and then take a picture of the second page. And then you could do them all, but let's just do 2 pages. I just really wanted you to practice using that app so that you knew how to do it. And so save that, and then what most people do, what I do, is I usually just email it to myself. And then when I get to my computer later, I upload it. Does that make sense? So yeah, you can make it prettier, so that's definitely appreciated because I'm gonna have to look at all of those. But then if you go to D2L under activities and assignments, there is literally an assignment, an upload file that says something like CAM scanner practice or something like that. And that's what you'll upload it to. So the real purpose in that was for y'all to just practice using CAM scanner so that it wasn't like the first time you used it when you were trying to do this test that I was mentioning.